Hello friends, in this video we will discuss about plasma parameter and number of particles in device pair. The picture of device shielding is valid only if there are enough particles in the charge cloud. If there are one or two particles only in the sheath or a sphere, the device shielding would not be satisfied the statistical concept. We can compute the number of ND particles in the device pair by the formula capital ND is equal to small n 4 by 3 pi lambda d cube. By calculating these values, we get 1.38 into 10 raised to the power 6 t raised to the power 3 by 2 by n raised to the power 1 by 2, where T is the temperature calculating in the term of Kelvin. In addition to lambda d should be much less than in the whole dimension of the plasma. This is the collective behavior which is required for condition to be plasma. By this we can say ND should be greater than 1, where ND is the number of particles within the device pair. Now we will discuss the criteria for plasma for any ionized gas. First, the device length lambda d should be much less than the entire dimension of the plasma. Lambda d much less than to the capital L, where capital L is the whole dimension of plasma. Second criteria is the number of particles inside the device pair, which is given by ND is equal to small n 4 by 3 pi lambda d cube. The lambda d should be greater than equal to 1. Now we will see the third criteria from an example. Suppose the ionized gas in an airplane's jet exhaust does not qualify a plasma criteria because the charged particles collide infrequently with the neutral atom in their random motion, which is controlled by ordinary hydrodynamic forces rather than the electromagnetic forces. If omega is the frequency of plasma oscillation and tau is the mean time between collisions, then the neutral atom we required omega tau should be greater than 1 for the gas to behave like a plasma rather than a neutral gas. These are the three conditions for a plasma that satisfy by a gas to set to be a plasma gas. Now we will discuss about the plasma temperature. It is an interesting fact that plasma have several temperatures at the same time, that is Ti and Te. As temperature depends upon kinetic energy and the rate of collision between the ions, different than the electron collision, so have different temperatures. Also the single species, the ion may have different temperature Tt and T up, where the component of velocity which is parallel and perpendicular to the magnetic field B.